Thank you, Jeff, and thank you for our three wonderful panelists. I am Mei. I am the lead data analyst from the Mobility House. Very happy to be here today and share a little bit about how analytical and modeling tools can be used to support electrification. So for today, first, I will use a case study focusing on a project we completed recently with NYCSBUS. And then I will talk about some other common questions people have experienced during different stages of electrification that modeling can help address. This case study is with NYCSBUS on their Zarega sites, which in that they are now in the process of electrifying. And earlier this year, when we started talking to the utility, we realized that there is a limit of power connection on the utility side for this site. And there's only 80 kilowatt power on the site. So this question very naturally came to us. We have to figure out how many vehicles can be put into the site with the limited on-site power. And at that time, NYCSBUS has already decided that they would be using 19.2 kilowatt L2 AC chargers. So if you're thinking about this problem, a very straightforward way of calculation to understand the number of chargers we can fit in with the 80 kilowatt power would be to divide this 80 kilowatt by the full power of charger, and that will give you number 4. So 4 chargers can be fit in if they are all operating with full power. But this number for a big bus fleet like NYCSBUS with ambitious electrification goal is a little underwhelming. But the good news is that that's not the only way you can utilize your power connection. And there are other technologies that will enable you to use the power a lot more efficiently. And to illustrate what I mean, I would like to invite everybody to do a thought experiment with me. So imagine that there is this magical switch, which would automatically switch chargers on and off. And when the charger is charging a vehicle and the vehicle is fully charged, then this magical switch will just turn off this charger and turn on another charger that will charge another vehicle. And if we have each vehicle and each of them have 4 hours to be fully charged, and we have 12 hours at night where all these vehicles are available, then we can easily fit in 3 chargers with using only the power of 1 charger. That is less than 20 kilowatt. And it's worth noting that there's no need for any manual intervention. So this is a magical automatic switch. And in that way, we can stagger charging, and we will be able to install 3 chargers with 20 kilowatt. And in the same spirit, when we have 80 kilowatt, we would be able to install 12 chargers. Well, and I would love to say that this magical switch actually exists, and we've been talking about it, and that's why what we're referring to as the charge management system. But I think you got a hint that the calculation where you have to consider this charge management is pretty complicated, and that's why we have a tool to do that. We have to understand how long it takes for each bus to be fully electrified, fully charged, and we have to understand how much energy each vehicle needs to be fully charged. And these are some of the factors you have to consider to answer those questions. For example, you have to understand what's the physical connection and what is the vehicle spec, what's the vehicle schedule, and what does the charger setup look like. And even more importantly, we've been talking about the cost to charge vehicles. So in that way, you also have to consider what's the utility rate. And for the NYCSBUS study, we used this tool and we took all these factors into consideration to answer this question of how many vehicles can be electrified with this on-site 80 kilowatt power. And this number we find out to be 18 school buses with the 80 kilowatt power, in contrast to the 4 buses that we would be able to do if we don't have any charge management consideration. And this 18 number was able to inform NYCSBUS's decision. It was not the final number of vehicles they decided to bring on site because there were other considerations about physical parking constraint and what makes an easy installation after thinking all about charger installation as well. But I just want to share this case study with you to kind of go through the thinking process and what kind of complications there could be when you're in the planning stage. And here we also have an illustration of how the load would look like if you were to bring all these 18 buses into site. And you can see clearly that we will be able to manage the charging of all these 18 buses with 77 kilowatt, where you don't have charge management to electrify the same amount of buses. You would need a lot more than 80 kilowatt to make that happen. So that's the end of the case study. And I would want to talk a little more about what other questions modeling can help answer, depending on what stage of electrification you are. So if you are in the early stage, we're still trying to understand if it's at all feasible to electrify. You might be wondering what routes are feasible to electrify and how many routes can I electrify if I have a limit of power connection on site. And if you are further down the road where maybe you have purchased your vehicle and you've made a plan on electrifying certain routes first, then you might be thinking about chargers and infrastructure planning. You will be asking, what chargers should I consider? And how many of each of these chargers should I install to make sure the operation is successful? And people might, if you're more on the financial side of consideration, you might be asking, how much is charging actually going to cost? And what is the optimal way to charge my vehicle that is economically effective? We've also had customers who had a microgrid system on site with solar and battery, maybe on-site generator, which will make this whole consideration of electrification a little more complicated, because then you have to consider the existence of extra power coming from battery, coming from solar. And questions we can, in that case, help answer would be, for example, can my current solar array power my fleet? And what does the operation of fleet will look like if I have to consider solar and maximizing the utilization of solar power generation? And the last one is not super common, but we've had some adventurous customers and who are interested to explore more advanced charging technologies like bidirectional charging and discharging. And that way, we've had people asking, what is the available vehicle to X programs available in the area? And what's the consideration? What's the estimated benefit of participating in these programs? And how can I get there if I'm interested? So these are all questions I have experienced customer asking with my work at Mobility House. And these are questions that luckily can be addressed with modeling and analytical tools. So with that, this is the end of my presentation, and I will hand it over to Jeff.
Yeah, thank you so much, Mei. Yeah, just to highlight, talking to either the Mobility House or other charging and energy management systems before you do your project can really help you plan your project effectively and efficiently. Mei is one of our data analysts, and she's always happy to help look into a site before we even ever start work or have a contract signed. We want to make sure that electrification is right for you. Electrification can't solve every route at the moment, but as technology progresses, it's going to get better and better, and we're here to advise, hey, can we meet your needs, or what infrastructure do you need to meet your needs? That is something that we can very, very specifically help you with. So don't hesitate to reach out. My contact information is here. And if I can't answer your question, I have a team of over 300 folks who I'm sure would be able to help out.